Alright, dear children, now we go to the relation part of this chapter, wave. Okay, and especially the relation that we are going to derive is among three different parameters, okay, connected to wave, sorry, and one is frequency, wave velocity, and wavelength. Okay, that means we derive the relation between frequency, wave velocity, and wavelength of a wave. Okay, now this relation is important, okay, as far as the wave motion and the characteristic wave motion is concerned. Okay, now for that, for the relation to be derived, okay, let me just start with this one. Okay, now you know that we know the definition of wavelength. Now wavelength is the distance traveled by the wave in one complete oscillation. So for one complete oscillation, whatever distance that is traveled by the wave is called wavelength. Now I write down that distance traveled, okay, distance traveled by a wave for one complete oscillation, one complete oscillation is actually equals to the wavelength. This is actually equals to the wavelength of a wave. But you know, distance traveled by wave for one complete oscillation means equals to how much, in how many seconds the one complete oscillation will cover, equals to time period second. That means, you know, distance travel, time taken by the wave to have one complete oscillation is how much, is equals to what period? Time period. So in one complete oscillation, how much time is taken by the wave? That is equals to time period. So I write down, therefore, distance traveled, okay, in how much second? T second. Now you know T is the symbol for time period. Now T second means for one complete oscillation. T second also for one complete oscillation. Also for one complete oscillation. So distance traveled by a wave in one complete oscillation means distance traveled in T second is equals to the wavelength. That is equals to the what? Wavelength. And you know what is the symbol of wavelength? Lambda. We know the symbol of wavelength that we write as what? Lambda. So in time T second, the distance traveled by a wave is once wave that is equal to wavelength. Then I write down the distance traveled in 1 second. How many second? 1 second equals to lambda by what? T. In T second, distance travel equals to wavelength, then distance travel in 1 second equals to lambda by T, or wavelength by time period. Okay, but you know distance travel by wave in 1 second is also called what? Velocity, wave velocity. Okay, this is also called what? Velocity, wave velocity. You know wave velocity marked by letter what? B equals to lambda by what? T. Because B is nothing but the wave velocity. This is called what? Wave velocity. And wave velocity, as per the definition we have defined, is nothing but the distance traveled. It is nothing but the distance what? Traveled. Okay, in how many second? 1 second. Distance traveled by the wave in 1 second is called wave velocity. Okay, so B equals to lambda by T. Now if B is lambda by T, but you know that N means the frequency. You can write F also, you can write nu also, but I am using N, or you can use nu also. Yes, in some case you can use N, nu as the symbol of frequency also. So N or nu, which is the frequency, and this frequency is always reciprocal of what period? Time period. We know frequency and reciprocal time period are always reciprocal to each other, which means I write down now this wave velocity equals to wavelength into 1 by T. So just writing lambda by T as lambda into 1 by T. Now this 1 by T is nothing but N or nu. N or what? Nu. Which means the wave velocity or wave speed equals to wavelength, this wavelength into what? N. N means the frequency. Okay, so finally the relation is wave speed or wave velocity equals to frequency into wavelength. So frequency into what? Wavelength. Or we can also write this as wave velocity equals to nu into lambda. See, in some book you can find using this symbol of frequency as N, or in some book we can find the frequency using symbol as nu. So any of the symbol we use, but frequency, wave velocity is always the product of frequency and the wavelength. Product of frequency and the wavelength, which means the final case is wave velocity is nothing but the product of frequency into what? Wavelength. See, the product of frequency and wavelength measure the what velocity? Wave velocity. So this is the relation that measure the what velocity? Wave velocity. So it gives the relation between speed, wave speed, frequency and wavelength. So wave speed or velocity is always equals to frequency into what? Wavelength. Now this relation actually we need especially for the calculation part, okay, of the topic that we need to discuss from this unit, that is unit number 10, oscillation and wave. Now in the next YouTube video we will be learning, okay, a topic, and this topic is called a plane progressive wave and the displacement equation of what? Plane progressive wave.